Hey class. Welcome to Physics 1 COVID edition. I am your professor, Dr. Aaron Lee. Professor Lee, Dr. Lee is fine. And today I thought we could talk a little bit about kind of what this course is going to look like and feel like, where we're going in the course, and kind of introduce you to some of the tools that will help us be successful this semester. There will be some unique challenges, let's be honest. But I'm confident we can persist and we can do this well. And hopefully have fun along the way. All right, so to the freshmen, welcome to St. Mary's. Those of you who are on campus, hopefully we can chat at some point. I will offer some sort of in-person office hours for those who live on campus and are interested. I will find myself on campus a lot. I'm currently in my office. We're not allowed to have students in our offices this semester, so we will have to figure out an outdoor office hours sort of scenario. To those who are returning, welcome back, whatever that means. I imagine most of you are living remotely this semester. Yes, this is definitely one for the memoirs. I think when we look back at this year, while I don't think we will necessarily remember it fondly, hopefully we get to a point where we can laugh and realize that we became stronger in a tighter community as a result. All right, let's see. Let's talk a little bit about how this class is going to run, and let me show you some of the tools that we will be using this semester. So I have this kind of swanky setup. We'll see how long I can pull this off, where you can have video where you can actually see me as a person rather than just looking at a slide deck or a screen. There will be, some sort of media that I can work in as well. There will be, in addition to that, there will be. I'm realizing the screen has stopped mirroring. Allow me to show all. Ooh, that was way too big. There will be opportunities for me to kind of write on my iPad, so that if there's some sort of media that it's worth me kind of drawing out, I can do that here. This might be useful for, say, if we're looking at plots. It looks a little cleaner if I can show it on a screen and can identify useful features that we're talking about or whatnot. So that will be helpful as well. Also, I got this kind of fun additional screen set up where, if necessary, I can write on the whiteboard if we have to. And I can also, there might be some real-time demos that is kind of worth me doing in real time rather than pre-recording. So we have that set up as well. Again, we will see how long I can pull this off. I'm doing this for 4 lectures a week. I welcome any encouragement and enthusiasm. All right, let's see here. So again, the lectures will operate, well, the entire class will operate fully remotely. The lectures will be pre-recorded and available on this YouTube channel. So you should have gotten a link to this first lecture. It should have taken you to some sort of YouTube channel, which is where all of the lectures will appear. It is assumed that you will be on top of things and responsible for making sure you watch these lectures. We will have some synchronous meetings as well that will go over the content, but that really only works if you have come prepared, having watched the lectures, coming with questions that you have about the lectures, and then we'll be working on problems in groups that will reinforce what we've covered in lecture. So again, if you're not watching the lectures and you fall behind, then those synchronous sessions are not going to be nearly as useful. To kind of help you, if you've looked at the syllabus, you might have noticed that I will occasionally also have like very short little pop quizzes at the beginning of some of the synchronous sessions, and I won't tell you which, that will be very simple questions that if you are watching the lectures and paying attention to the lectures, they'll be very simple and easy for you to answer. And it's worth, I think I had those quizzes as 10% of your final grade. So it is a non-negligible amount of your final grade. I guess on the synchronous session, so there will be 4 pre-recorded lectures a week, and then everyone in this class will attend 2 out of the 4 synchronous sessions every week. So For example, if you're in section 2, then on VL Express or on your course schedule, it has you listed that you would come to Physics 1 roughly 8 to 9 a.m. Monday, Tuesday, Wednesday, Friday. Now, you won't have to actually come 4 days a week. You instead, on Moodle, which I'll go over in a little bit, is I will break every section into 2 blocks, and then so block A might attend the Monday and Wednesday synchronous session, and then block B will attend the Tuesday and Friday synchronous session. And it really is important that you stick with the block that you're assigned. It's not a come to whichever works. We can shuffle around a little bit if there is something about your schedule that helps. Like we have some international students where later is more helpful for them, so we can shuffle around a little bit. But the idea is that everything runs a little bit slower online, and if I have to hop between groups in Zoom, it'll be more helpful for you and easier for me if we keep the number of people in each section or each block to about 10 students or so that we can have kind of 3 groups of maybe 3 people each. So it's much easier for me to hop around to 3 different groups online compared to having to hop around to 5 different groups or something like that. So that is the idea. So stay tuned on Moodle. There'll be more information about which block you're in. And again, we can do some reshuffling at the beginning, but once those kind of settle down, our schedule settles down, the idea is that you will be attending, you will not be switching out your block, for the remainder of the semester. And in those sessions, what will happen is they will occur synchronously. I probably will not record them because, again, the idea is that it's going to be recaps on the lecture where if you have questions, you can ask questions. I will recap kind of what is I find important, so maybe that component could be recorded. But the majority of that time will be spent you kind of breaking on into groups, working on worksheets together, and then we will be coming back as a full class discussion to go over those problems. So this, in other universities, this might be called like a discussion section or a recitation section. That's kind of how I'm structuring the course. Typically, it's just 4 lectures where there's kind of group work interspersed in between, in all 4 lectures. Now I'm kind of structuring it like, say, how I remember taking classes at Berkeley or Northwestern, where I had lecture and then I had a separate component, which was the recitation section, which is where all the problem solving was, which is kind of how I'm running these synchronous sessions. This actually gives us more time to cover content and do problems. So, trying to find silver linings in all of this. Usually I get a lot of requests to do more problems, and I think this will be a way that I can help you all do more problems, which will obviously help you prepare for the work in the exams. All right, I don't think I've had any more. And then on top of that, there'll be various assignments. So there will be a weekly problem set that you turn in on Expert TA, which will be the topic of Lecture 2. So I'll talk about the homework system tomorrow, or Lecture 2. The synchronous sessions, again, as a way to make sure that you're staying on top of things and as a way for me to kind of take attendance. You will work on group problems together, and you will turn all of that in at the end of the session, and it will be graded primarily based on whether or not you were there, present, and actually trying. You don't necessarily have to have everything correct. But it's just a way to hold us all a little bit more accountable. It's kind of easy to get kind of lost and distracted by a lot of things, especially when we're doing this remotely. So that is a means to, the kind of attendance taking and this occasional quizzes is meant to help you kind of just make sure that we all remain on track. That kind of rapid feedback also allows me more of an opportunity to provide assistance if I notice that a lot of people are having problems with certain ideas or topics. And as the syllabus will describe, you might think, oh man, I have to come to every single lecture, like what if something comes up? Don't worry, there are contingencies worked in where I only keep, I think, the top 90 or 85% of the grades, so you do have some wiggle room if you miss some classes. But the idea is that you should try your hardest to not fall behind. And if stuff comes up where you feel like you are going to fall behind, maybe something happens, outside of school that you have to address or deal with, let's just keep open communication with each other, and I'm happy to work with you to make sure that we all succeed in this course. All right, so I wanted to, with that, the returning students are already going to be very familiar with this. But for the freshmen, if you have not played around with Moodle yet, let's go to our course Moodle page and look at it for a little bit. So you should get very familiar kind of accessing My SMC as some sort of portal that allows you to access all St. Mary's things related. Once you sign in, yours might look a little bit different than this, but you should have some sort of link to Moodle, your email, for example, in your Google Drive, and those 3 items are going to be important for us moving forward. Google Drive is where I will share most of my files and folders with you, and actually as we interact through the synchronous sessions, we will be sharing files with each other over Google Drive and working synchronously on them. So familiarizing yourself with Google Drive will be important. You should get in the habit, if you're not already, of checking your St. Mary's email often, and try to use your St. Mary's email when contacting me and other people that have St. Mary's emails. I've noticed, I think the Google artificial intelligence algorithms get a little confused in that since I get inundated with so many St. Mary's emails to my St. Mary's email, it thinks anything that's not from stmarys-ca.edu is spam. And a lot of student emails will get lost as a result, or be thrown into the spam folder by accident. So try to, whenever you're contacting me or other people with St. Mary's emails, to use your St. Mary's email when writing those emails and responses. All right, and then the other link is Moodle, which you will become very familiar with as you navigate St. Mary's. So it should load up some sort of dashboard like this. Help us, the professors, if you want to, put a profile picture of yourself up that's attached to your Moodle account. It's helpful to help us learn names. Obviously not required, and only put what you're comfortable with. But a filled out Moodle profile can be very helpful for us. All right, and I'm sure there's quicker, better ways of doing this, but usually the way I do this is I view my dashboard, and on the dashboard will be a list of all the courses I've ever been and am currently in related to St. Mary's and Moodle. This is actually only my 2nd year at St. Mary's, so I'm sure a lot of the older students have much larger lists than I do. The habit I kind of get in the habit of is that I click as my favorites the courses that are relevant for this particular semester, so that when it loads up on favorites, it's only looking at this semester's courses, not the slew of all the Moodle courses I've ever been in. So in this case, this class will use the one that is Physics 1, Section 1-2 combined. I think there is one for Physics 1, Section 1 that still exists, but is empty and will remain empty. I'm not going to ever edit it again. So make sure you are always accessing this one where it appears as Physics 1, Section 1-2 combined. When you get to this, actually, I can make it look like you. So right now, you're seeing it as I see it as an instructor. But for the student, you might see something that kind of appears like this. This is kind of our home base, where all the information that is relevant to this course will be kept or can be funneled through. The top of the page has very important links that I put at the top so you can easily access. All our synchronous sessions that occur during the week will occur in this Zoom room, so that is the link you have to go to when you're attending the synchronous sessions. And it should not change throughout the entire semester. Expert TA, this is the link to the online homework website, which again I will talk about more tomorrow. And the third important link is making an office hours appointment with me. I might change this a little bit, where the physics faculty are still trying to figure it out, because we want to try to have also some communal office hours where all the physics faculty are available. But for right now, you can sign up for individual appointments with me. So with this, if you click this, you should be taken to some sort of link. It will appear, if you've been using your Google Calendar, things that you have on your Google Calendar might also appear here, like this video appointment I had yesterday with my Kaiser doctor. But then there should also be places where you can sign up for office hours, and the idea is that you can find a time that works for you, click on it, and then I don't really think you actually need to fill any of this out. If you save it, it will associate your St. Mary's email or whatever Gmail you're signed into. Try to do it through your St. Mary's email. And then you should get an email notification, I should get an email notification, and it will then appear on my schedule as, when I look at my own calendar, it will appear, here's an example of, a student that booked a time to chat earlier this week. So, that is kind of the easiest way I've thought of doing this for now, since I can't just have an open door policy where you can just wander in, but some of this might change, so stay tuned, we'll play it by ear. All right, other things that are relevant, you will see kind of relevant course information. Things that are important, I guess, let me see before I scroll down. The grade book is going to be something that's going to be very important to you. So all your grades, I won't click on it because it shows all the students and their personal information on my end. But this will allow you to access kind of the grades that are being logged for this course, how different scores are being weighted properly, and kind of helps you get a sense of where you're going and how you're doing this class. And whatever is on Moodle, I guess I should say this now, whatever is on Moodle is what I will use to determine final grades. So even though we'll be doing things, collaboratively in class, you'll be doing online homework and on a different software, all that information is going to get collated into Moodle's gradebook, and that at the end of the semester is what I'm going to use to determine final grades. So it is your responsibility to make sure that the grades that appear on Moodle are up to date and correct. Because sometimes transcription errors happen. My TA might accidentally transcribe something incorrectly, and we should not hold it against them. But if you notice that something's wrong, just reach out and we can make sure that everything is reflected accurately. All right, let's see. So then there are a couple links that, before you get to the tabs, that are going to be important. Any announcements I send, you will get an email notification about it as well. But you can always see old copies of these things here in the Announcements tab. So the one I sent a day or two ago, at least as of this recording, can be here if you want to review that. The class, and only I can post to the announcements. The class forum is similar, but it is an open forum where anyone can post questions. You should not get email notifications for everyone that's post. So this is a place where if you have questions about concepts or homework or want to form a study group, or are trying to organize something around the homework, anything that might be relevant for this class, I encourage you to use this forum to post discussion topics, reach out if you want to try to form study groups. And if there are questions that you can ask via text that don't require office hours, you can also ask questions to me, and I will try to make sure I check this every other day or so and get you some feedback. All right. Next important link, the Google Drive folder. So this is the folder that everything relevant and important to this course will live. So you'll become very familiar with this. This will populate itself as the semester goes on. So again, the idea is that with your St. Mary's email, you should be able to access whatever is inside this folder, and anything, any handouts, copies of old exams, rubrics, the syllabus, all the up-to-date versions will live on this Google Drive. So as I update this Google Drive, the nice thing about using the Google Drive is as I update files in this Google Drive, all the things I've linked to elsewhere will then start to point to the most accurate up-to-date version. So I rather would just work in Moodle Drive rather than uploading files to Moodle and having to replace them, and that's about it. So right now there's not much besides the most current version of the syllabus. All our meeting handouts will go here. Study guides and rubrics, might exist here. There's something on, if you want to review the map in this course, there's something I put up there. And then course materials for right now, I think it's just the first 2 chapters of the textbook, in case you haven't gotten it yet or are waiting for it to be shipped to you, as well as the table of contents. All right, so that will be important. And again, like I just said, this link to the syllabus will always point to whatever is the most up-to-date version in that Google Drive. So I don't have to, you shouldn't have to worry about links pointing you to the wrong thing. Flipgrid is related to another project that we'll be doing in this class, and I'm not going to talk about that right now. All right, and then below all that, so that will always be at the top, and then below all that is going to be sections that I will roughly break off into week by week. So the one at the very top, it will be a link to the lecture. So again, this will essentially just be a link to the YouTube playlist where all these lectures will live. Some general tools are tools that I've found kind of useful, especially now as we are navigating this increasingly remote and digital world. That might be helpful for you, especially if you are less familiar with, say, how to turn pictures into PDFs and how to upload PDFs and make documents and scan your work. That might be something that's relevant for the exams, where I might have you actually write out something on a piece of paper, take a photo, upload it, and that's how you turn in your exam. So this is not going to be the only class you have to do that. So familiarizing yourself with various tools, how you can do that for free. This is some of the information that faculty have found useful, some apps for iPhones, Google, Cam, and whatnot. That might be important. So you can check those out. This top thing was actually given to me at a faculty training session about how we're navigating this COVID world. And actually, I found the information so well laid out that I just copy and pasted it here. So this kind of gets to the attendance and COVID reporting flowchart for those who are living on and off campus. Obviously, for students, this is how you should operate based on these sets of rules of whether or not you start experiencing COVID-like symptoms, whether you end up having to quarantine yourself, or just general absences unrelated to the pandemic. So again, for those who are returning, most of this is probably not new. Since this is fully remote, since this class is fully remote, it's a little bit easier. Again, though, if you're living on campus and start exhibiting COVID-like symptoms, of course, you should report that to the Health and Wellness Center. If you're not sick but quarantined, then that should not impact you to continue on this course. Obviously, if you do end up getting sick, then we just need to have a conversation. Obviously, I will not hold it against you if you are recovering. I want you to recover as quickly as possible, so we just need to make sure we're on the same page. And then if you have other absences, maybe you get sick but not COVID-related, and maybe there's a death in the family, maybe something else happens, then all the general rules apply that you can access in your student handbook. And again, if you feel like you're going to be missing a considerable amount of class or risk falling behind, make sure we chat. Just make sure we're on the same page. And then similarly, I have my own protocols in place of what I need to do if I get sick. All right, and then from then on out, every week we'll kind of have the relevant things that I find relevant for that week. So there'll be links to maybe helpful videos online, PDFs, handouts, things that might be important for that particular week. All right, so that is kind of the Moodle page and the important parts of the Moodle page. With, again, some that I've not gone over, but I will go over in upcoming lectures. Let's now actually briefly go through the syllabus. I trust you are capable of reading the syllabus at some point, so you should familiarize yourself with the syllabus contents at some point. But let me highlight some of the important parts. Top stuff, various links, clickable links, again, if you want. My office, which again doesn't matter because but if you want to know where I eventually am, when we all want to high-five each other, when we survive all of this, in the spring, if you need to, you can find me in Galileo 103B. My email, if you need to contact me, please use my St. Mary's email. Again, Dr. Lee, Professor Lee, whatever is fine. Description about the course, I'll let you read that. So required materials. There should be only kind of 3, maybe 4 things. The textbook, this is it, or at least this is the 11th edition. The physical copy for the students, they're doing this weird thing where it's not bound like a book, but it's just essentially like a set of loose leaf paper that you should then just buy a binder and put it in. I think the appeal is that they are trying to encourage you to buy the digital version instead, but the good news is that if you do prefer a physical version, having it not be a bound hardcover textbook makes it much cheaper than physics textbooks usually run. And that book, the book that you buy, Fundamentals of Physics, will also apply for Physics 3. So you should not have to buy another textbook next semester for most of you who are continuing on to Physics 3 and 4. All right. Though I know most students, at least when I taught this last year, most students are just going to get the digital version. So I recommend that. You can buy it now. You can do it through the bookstore if you're using financial aid or prefer to do it that way. Or if you want to find it online, you can do it that way. The 11th or 10th edition should be fine. As it says on the 11th edition, it says previously sold as the 10th edition. So there actually is no difference between the 2 books. So whichever, if you can find a used copy, great. Or if you want to buy a digital version, great. We will never need anything super specific in the book. It will just be readings that are relevant, and then most of the problems that we do in class will be taken from the book. All right, so that's the book. Very important. Also, what will be important is how you do the homework, which is through the expert TA system. So there is a link kind of later down. Yes, there's a registration page, and again, I'll go over a little bit about this tomorrow, where you have, if you use this second link, you will be allowed to register for our class taught by Dr. Aaron Lee. And you will be a student then in the expert TA course, and that is where you will do the homework system. So the homework in Expertia I really like. It is not associated with the textbook, so the wording and the problems are slightly different than how the book describes it, which I actually like as a good thing, because it forces you to really think about the material and not about how the problems are being worded. So I like that. I like it in that regard. It helps me make sure that nothing nefarious is going on, because everyone will essentially get, while you'll be doing similar problems, all the numbers will be mixed up. So while I don't dare believe any of you will do anything like cheat or copy, don't, because if you do, you're going to get the wrong answer anyway. And it also it has a really good kind of adaptive real-time feedback, so it knows kind of what mistakes are common and can provide you help as you work on the homework. And allows you to try the homework problems multiple times before you submit it finally. So that will be very helpful. Unfortunately not free, but it's only like $30. And then you'll have to make an account on Flipgrid, which I will talk about a little bit later. It's essentially like a group Instagram page where we'll be posting videos and kind of posting little things where we talk about kind of and show off the physics that we're seeing in our everyday lives. There's also, I guess I forgot, there's also another thing that's on Moodle, which is this Kami PDF editor app. So we might work through Google Jamboard as our way to like interact synchronously. So the idea there is kind of like most things on Google, like multiple people can go into the same file at once, and if I write on my iPad over here, it's reflected on everyone else's screen no matter where you are. So Google Jamboard is essentially like an interactive whiteboard like that, but it just is very infuriating to me about how it handles PDFs. So we might actually, instead of using Google Jamboard, we might use Kami PDF Editor, which again is free and links with your Google Drive, but allows you to open up a PDF and then annotate directly on a PDF, which I think will make it a lot easier for us moving forward. And again, don't worry, if all of this is new, that is what we will be doing the first synchronous session, so Monday and Tuesday of the first week of class. So we will be going through this together. All right, and then that is what you should need, I think, just for Physics 1, and then Physics 2, the lab component of this course, Professor Rosario will reach out and will be sending you some materials to work on labs remotely. Course web pages, Moodle is the most important page, so as long as you have access to the Moodle page, you're good to go. Office hours we've already talked a little bit about. Class structure we've already talked a little bit about. Again, attendance and COVID, I alluded to this earlier. Again, attendance is very important because if you fall behind, it's really hard to catch back up, especially because I imagine this is not the only class you're taking. So do make every effort to stay on top of the lectures and to be attending your assigned synchronous session as often as possible. Again, though, if you get sick from COVID or something else, just notify me, notify the college. We will work with each other and figure out what is the best course of action. Technology requirements, I think most of us should be okay with this. Some sort of internet connection. Some sort of writing or tablet device, so like I have an iPad, people might have a Google tablet and a stylus. If you do not have something like that, don't worry. The physics department we bought a bunch of little tablet writers where it's essentially a little stylus and just a little black board that you can connect via USB, and then you can write on it and have it appear on your screen. So it's not fancy like an iPad, but it gets the job done. And that just makes it a lot easier when we're writing equations, we're writing numbers. It's very hard to do that by typing on a keyboard. So I will be reaching out soon. If people want one of those to borrow for the semester, I'll be reaching out soon to see who wants one, and then we will mail them to you. Working speaker and microphone and webcam is the ideal setup. At least speaker and microphone. Webcam is ideal. Just because I think it's important, especially when we are all so remote from one another, just to remind ourselves that we are interacting with humans. All right. Let me talk a little bit about kind of the sorts of things we'll see in this class. I talked about the first stuff already. You'll be coming to class twice a week. Those in-class assignments you'll work on in groups. They will be graded, so you will submit as a group. You will submit one PDF to me, which will be evaluated. Again, I think I even say here, each assignment is graded out of 3 points. I imagine it will be 1 point if you turned in anything at all, so that's sort of an attendance point. 1 point if it seems like the group is working well together, so you'll each be working in a different color, and I'll be able to assess whether the groups are actually working as groups. And then there'll be 1 point based on whether you made it, significantly through the worksheet. It doesn't necessarily have to be entirely complete. It doesn't necessarily have to be entirely correct, but just to make sure that you actually are making some effort as you work together in class. And it looks like I said 90, so I will keep the top 90%. So if you have to miss, if you miss class, for any reason, don't worry, it's not the end of the day. Lecture quizzes. So again, the beginning of classes might have a very short problem just to make sure you're watching the lectures. The expert TA homework, there'll be roughly 1 a week of probably about 10 problems. So I think that amounts to 13 or 14 assignments total, and I will drop the lowest 3 grades. Late assignments are possible, but the total amount possible, decreases every additional day you're late. Flipgrid, I'll explain more about that soon. There'll be 3 exams, and then 1 final on top of that. How they're exactly going to look, I have not quite figured that out yet, so stay tuned. The grading policy kind of gives you a sense of how all of these things are weighted, so I'll let you take a look at that, and how if you do well on the final exam, that final exam can actually replace one of your other exam scores, so there's some incentive for you to do well in the final. So I'll let you take a look at that. And then some of the various accommodations I find helpful and useful, though the student handbook has a lot more of these that you should consult. The ones I'll point out is SDS, the Student Disability Service. If you need more additional time on exams, if you need other things that will help you be more successful in the class, do reach out to SDS. If you have done SDS in the past for the returning students, do remember you'll have to redo this every semester. And then I will get some sort of notification, and then we will have a private conversation to make sure that we're on the same page. Counseling and psychological services will have remote options for you to, if you need mental health assistance. So I encourage you to look at what CAPS it makes available to you. And then also there's the St. Mary's STEM Center, which is usually on the 2nd floor of Assumption Hall, but they offer remote tutoring and assistance in the STEM field. So I encourage you to look at what the STEM Center provides in terms of assistance. A lot of students have used that and have found it very helpful in the past, and they'll be offering, again, remote options for tutoring if you need tutoring. Beyond, say, office hours or working with each other. The SMC honor code, yada, yada, yada. At the end of the syllabus, which again, this will update as the semester goes on, gives you a kind of tentative course outline to kind of show you what each lecture is going to cover, what sort of reading you should be doing from the textbook that's related to those lectures, and then also gives you a sense of important deadlines and the topics that we'll be doing during the synchronous sessions. So, for example, just looking at the first week of class, you are currently watching Lecture 1. Lecture 2 will be on expert TA and other tools, and then we'll start in on some math review. Lecture 3 will be math review in 1D motion, and then we'll be off and running with kind of Chapter 2, which is on describing and quantifying 1D motion in physics. This is the relevant sections of the textbook you want to try to keep on top of. Again, the textbook is helpful because it describes things in a different way than I would have described it. So it's always helpful to have alternative ways of learning a topic. And then the synchronous meetings gives you a sense of what the synchronous meetings are going to cover. So again, there's only 2 things mentioned because if you're meeting on either Monday or Tuesday, the idea here is that those meeting on Monday or those meeting on Tuesday, those sessions will cover intro to the synchronous meeting tools. We'll just say hello to each other. Then those meeting during the synchronous sessions on Wednesday and Friday, those sessions will be covering, in this case, math review and thinking about physical units. So this gives you a sense, and then also relevant deadlines and notes. So the homeworks will be due before the start of class on every Monday. And then if there are no synchronous meetings, like this Monday is Labor Day, there'll still be a lecture because it's all remote and asynchronous, so holidays be damned. but we will not have synchronous meetings, of course, and acknowledge the holiday. And this gives you the schedule up to the first exam. I guess I'll briefly say something about the exams, and again, I'll remind us all of this closer to the date. The idea with the exams is that even though I have everyone broken up into 2 blocks, everyone will take the exam on Monday. So I will have the entire Section 1 take the exam during the time Section 1 meets on Monday. And everyone in Section 2 will take the exam during the Section 2 exam time on Monday, rather than having it spaced not only across 2 sections, but then also across 2 days. I'm not going to write 4 different exams. It's hard enough writing 2 different exams for the 2 sections. So everyone will take the exams on Monday, even if your block doesn't meet on Mondays. And again, reach out if that is unclear in any way. All right. So that is it, I think, for the syllabus. For the Moodle page, we have general kind of strategies of how you can navigate the online tools. Let me just talk a little bit about what we're going to do in this class. This class is Intro to Physics. I'd say it's kind of Intro to the Universe 101, because physics really is the science that underlies all the other fundamental sciences. Everything in this universe can be described by simple physical laws. So for those of you who are chem majors, bio majors, or are pursuing engineering or other fields of science, physics really is at the heart of everything that you are learning in your other science courses. Of course, you learn very specific and unique techniques on how to do science for your field, but at the heart of it really is physics. And what I really want people to take away from physics is that physics is about understanding the world around us. It is a language that allows us to ask why anything happens in the universe. And physics is capable of providing answers through experimentation, through the scientific method, through mathematical techniques. Physics allows us to answer all the why questions we could dream of. And what we learn in this class is going to be widely applicable to everything that we see in this universe. Now, Physics 1 typically covers, typically is called mechanics. So we'll be doing a lot of, boxes rolling down inclines and slinkies and pulleys, and we'll do some sound and gravity and planets and the Doppler effect and things related to waves and pendulums. So there's a lot of kind of mechanical motion with what we are talking about in this class, but really it is the underlying principles of those ideas that are completely widely applicable to the entire universe. And, for example, like the moon, the moon orbits around the Earth while the Earth orbits around the sun. That can be understood via the laws of gravity. It is also the reason why, for example, I can take this apple, throw it up into the air, and the apple falls back down and comes back to my hand. It is the same kind of law of physics, the law of gravity, that allows us to understand all these disparate, different phenomena. It is not the case where you have a different law or a different equation or a different rule for each of these individual things. They all can be understood with the same basic few equations and ideas. All of what we will be learning about in this course also plays a very important role in what we will talk about in Physics 3. Electronics, electromagnetism, nuclear physics, which is more modern, which is more Physics 60, but all of these ideas, while these are kind of very different than, say, gravity, they can be understood through kind of the same simple, basic, fundamental laws of motion, particularly Newton's laws of motion. The emphasis here is that it's the same kind of basic principles that allow you to understand, say, why an apple falls back down to the ground when I throw it in the air versus why your Apple iPhone works at all. It's these same laws of physics that allows us to describe all these various different phenomena. Or, for example, why SpaceX rockets can get to the International Space Station or can get into space and off the Earth at all. Again, same ideas behind the laws of gravity for why the moon orbits the Earth and why an apple returns down to my hand. I should say, as it might be clear, my PhD is actually in astrophysics, particularly. So expect a lot of space examples. But just to really nail home this point, again, these same basic laws, Newton's laws, and in this case, the law of gravity, cannot be only used to understand why apples fall to the ground, why the moon orbits the Earth, why rockets can leave the surface of the Earth, but also allows us to explain how entire galaxies like the Milky Way and like the billions of other galaxies that we've observed, each one of these things you're seeing on the image is a different galaxy, which each of them having hundreds of billions of stars. Each of those stars likely have planets orbiting around them. Those planets might have moons. It's all the same, essentially 3 or 4 equations that can be used to understand all of that. That's it. Yes. So some of the things that we'll be learning about is, we will start with a discussion of mechanics and how you describe motion. What is the mathematics behind how you describe motion? So we'll be talking about position, velocities, accelerations. And then from that, we will use those tools to understand the laws, physics, in terms of physics, Newton's laws of motion. So there are 3 laws of motion that are going to be incredibly important for the rest of this semester and for physics 3 and 4. So Newton's 3 laws of motion essentially allow us to understand a wide variety of phenomena. So that's kind of going to be Act 1 of the course. Act 2 of the course is what I call the great conservation laws. So we are going to learn about, there are a couple fundamental quantities called energy, momentum, and angular momentum. And again, we will learn what those mean. And it turns out, if you define them in the right way and understand how they can be given from one object to another, they are conserved quantities. So that means that, so an analogy might be, if I have $100 and $1 bills, and we all meet in a classroom, I can distribute that $100 in various ways, and we can all be exchanging money with one another. And while each one of us individually might have a different amount of money on hand at a given point in time, nonetheless, it's always true that overall there's only $100 in that classroom. The $100 is a conserved quantity. Money is not being created or destroyed in that case. The same ideas can be applied to energy, momentum, and angular momentum. And if you use those three conservation laws actually allow you to understand an incredible amount just by requiring that those quantities are conserved. Energy. Energy is one of those examples where you have probably used the word energy in the past, but it's an example of how we're going to have to learn that the language we use in physics is very precise and particular. So energy has a very particular meaning in physics that we're going to have to learn about and understand, so that when we talk about energy and the conservation of energy, we have to make sure we're speaking the same language. Momentum has to do with motion, so it's the idea of how you can conserve motion. And then angular momentum is the motion that's involved with rotation. And that is, I think, a really fun topic, but it's also a fairly abstract topic. So actually, I have a demo I recorded today. So let me get rid of this. I guess I'm going to get rid of this. So here's a demo I made today with the lab assistant for this course. So the idea here is I have a big wheel that is free to rotate, and I have a string attached to one side of it, and the wheel not rotating. If I just let go, it falls. I do it again, it falls. Your mind might not be blown at this point. But what we're going to do is we're going to do the same experiment, but we're going to get the wheel rotating really rapidly first. And then again, I'm just going to hold it by that cord, not touching the wheel at all, just letting the wheel, which is rotating and still has gravity pulling down on it. What happens when rotation is introduced? So here we go. So again, I'm going to just hold it by the string. In this case, the wheel does not fall over. It actually continues and remains straight up while it rotates. So am I tricking you? Is this magic? This is something that's related to what we'll soon called conservation of angular momentum. Something that is rotating wants to remain rotating in the same way. So that is something that will be kind of fun for us to think about in this course. And I think this is a good point to point out is, maybe you missed something, maybe you want to see that again. One of the perks about this all being recorded is that you can go back. I don't have to necessarily always make sure I repeat myself all the time for these videos, because you can always just go back and rewatch it as many times as you need, which kind of makes it nice. And I will try to do my best to, in the description below, have timestamps that will allow you to easily hop to different topics that are covered in the course. All right. So the last thing I wanted to just talk about, and then we'll call it a day, is what is science? Physics, chemistry, biology, mathematics. These are all things that are usually associated with science and the scientific method. But if you had to think about what science is, how would you answer? If you had to explain to someone who has never taken a science class what is science, how would you go about answering this question? Now, doing a quick Google search, usually provides you with something that has something to do with the scientific method. But then I have images like this, which are nonsense. I don't know what any of this means. I'm sure there's some cutesy explanation, but this is not what I would call the scientific method. The scientific method is all about trying to understand the world around us by doing experiments. Physics, like all other sciences, require data. It requires validation. It requires us to understand the world around us by having experiments being done and analyzed. So in elementary or high school, you might have seen something like this. This is kind of a very simple way of thinking about the scientific method. You ask a question, you gather information, you form a hypothesis, you test that hypothesis, you share the results. This is okay. It's cute. It's simple. If it's in elementary school, obviously this is kind of a very simple way of how you might describe how science is done. But you have all, even if you think you might be afraid of science, you have all done science in some way. You have done the scientific method in some way. It usually doesn't look like this, though. It usually looks something a little messier, where you have some question, you try to investigate that question, things don't work out, or maybe it introduces new questions, so then you go back, and you try again. You try to replicate your answers, but have a hard time doing that. Science is incredibly messy. So the idea behind how I think about science is, you're making observations, you're trying to understand nature. And to do that, you want to try to understand nature in a way that is verifiable and reproducible. Reproducible is the key word. That you can do the same experiment over and over and over again and get the same result. That is a solid scientific experiment. So the way you can go about this is you might think, you have to form a hypothesis, which is good. But the way I would describe it is actually, you have something that you're trying to observe in nature, something you want to try to understand, and it could be, is the moon made of cheese? Okay? My question that I want to investigate is the moon made of cheese? So what I should do when I formulate a hypothesis, really what I'm doing is I'm thinking of, there are at least two different answers that it could be. In this case, either it is made of cheese or it is not made of cheese. If you're doing another experiment, the idea is to come up with at least two possible answers that you want to try to distinguish between when you do an experiment. And then developing and doing the experiment is actually you are coming up with an experiment that will allow you to distinguish between the two. So the experiment might be go to the moon, scoop up a piece of the moon, take a bite, use that data to just determine if it is indeed or not made of cheese. Could be one experiment that would allow me to distinguish between it is cheese or it's not cheese. But you could think of how even that might not even be the best experiment to do, because what if it's a cheese I've never tasted before, so I might not know that I'm eating cheese, so maybe that's not even the best experiment. That's kind of how messy science can get with stuff like that, is you're constantly thinking of ways to distinguish from one result from another, and that is constantly being refined and expanded and rejected and reformulated, and you kind of get this very cyclical process. It's not a nice kind of here's the start, here's the end. It's constantly just this ongoing cycle. And again, every time you have tried to just figure something out, you are doing science. That is science. You are trying to figure out your smartphone for the first time, or you are trying to navigate all this new software that we're doing. You are making, you have ideas that you are testing and working and playing around with. You are doing, in essence, the scientific method as you are navigating all of these things. But again, obviously, with the physical sciences and with the STEM fields, we can refine this idea a little bit and get the sort of scientific method, the scientific process, which I like to just think of it as science is just incredibly messy. Is that you have some sort of question you're investigating, you have possible solutions, you then design the experiment. Usually you design the experiment based on what your hypothesis is and what the question is you want to investigate. You design the experiment so that you can distinguish between the two answers, you think. It doesn't do any good if I designed an experiment that actually didn't tell me whether or not the moon is made of cheese. You could think of, okay, my experiment is going to be, I'm going to go to the moon and then pick up a piece of the moon and see if it's heavy or light. That actually doesn't help me determine if it's cheese or not, for example. So that would not necessarily be a good experiment for that question and those two hypotheses that I had. With the idea, ultimately, that you are reaching evidence-based conclusion on what you are doing. So examples of what is pseudoscience or not science. Sorry for those who follow it, but horoscopes, the zodiac. The zodiac have a rich origin as the first kind of calendar. Because the zodiac actually originates because it is the 12 constellations the sun moves through over the course of a year. So the reason that Pisces is associated with March is because the sun is moving through the Pisces constellation in March. But whether that means that all people in March are sensitive introverts, there is no data to support that scientific experiment. Or pseudoscience, we're just popularizing ideas of just here's this image of a face on, I forget if this is Mars or the moon or some other planet, and using that to mean, well, clearly that's an alien statue. Nothing says it's not, but also nothing supports that it is. We would have to do other experiments that allow us to distinguish from one result or the other. All right. So that is kind of where we are going in this course. I guess I didn't even finish that. So then the second act is going to be the conservation laws. And kind of based on the scientific method, how we come to arrive at these conservation laws. And then the third act of the course, sorry, I'm doing this out of order. The third act of the course, once we know Newton's laws, once we know the conservation laws, we are then going to use them to understand a wide variety of different phenomena. So we will do gravity, for example. We'll do pendulums and what we call simple harmonic motion, or motion that oscillates back and forth. We'll use that to understand waves in general. So we'll look at sound waves and maybe even light waves. And then things like the Doppler effect arise when we think about stuff like that. And then we'll do a little bit of thermodynamics and temperature at the end of the course. And then that will set you up for electromagnetism, which is in Physics 3, which again, will continue using Newton's laws and the conservation laws to understand even more about the universe that we live in. All right, that's good for now. So we'll call this lecture 1 is in the books. So again, looking forward to this class, and I will see you all in Zoom soon.